Welcome back to my channel. So this is a question from physics under the topic motion. Okay, let's read the question. A stone is thrown vertically upward with an initial velocity u meter per second. Okay, it reaches a maximum height and returns to the ground. We have to find two things here. One, find an expression for the maximum height. Number two, find the velocity on hitting the ground. Before we start solving, let's take note of, this is the solution. This is initial velocity, right? Why this is what? The final velocity. This is the final, this is what? Initial, right? Why this is G is what? Is the gravitational force. G is the gravitational force, right? If an object is coming vertically downward, the initial velocity will be what? Zero. Please take note. If an object is coming vertically downward, are you getting it? The initial velocity will be what? Will be zero. But if the object, the ground state, and is going vertically upward, the final velocity will be what? Zero. So please take note of this, okay? If the object is coming from up, I get it, the initial velocity will be zero, but if it's going upward, then the final velocity will be zero. Secondly, take note of this. If the object is coming vertically downward, is coming from up, the G, which is gravitational force, is what? Plus, positive. Okay, but if the object is going up from its initial state, is going up, the gravitational force will be what? Negative. So take note of these four things. We want to apply them here. Okay, let's read it again. A stone is thrown vertically upward with an initial velocity u. Are you getting it now? It reaches a maximum height and return to the ground. Find the what? Maximum height. So let's first of all calculate for this one, the maximum height. I know in the study of motion, we have what? Different formulas which we can use, right? Make sure you write these things down, okay? Write them down. So we have almost how many formulas? We have three main formulas which we are using in calculation under motion, right? The first one is V equal to U plus AT, V square equal to U square plus what? 2AS, and what? S equal to UT plus half AT square. So you know these formulas, right? But in this type of question, you can only use this one if the equation is in horizontal form, like distance, like a particular object is moving from here to here, is in distance form. Are you getting it? But in this type of equation, the object is what? Moving vertical up and downward. So you must change everything. Okay. So in place of acceleration, A, you put what? You change it to G. So you can write them in this form, like V equal to U plus GT, right? Why the second one? V square equal to what? U square plus 2GH. Okay, 2GH. You know these formulas. Why the last one is H equal to UT plus what? Half GT square. So if it's in horizontal form, we can use these formulas, but if it's in vertical form, we use these formulas. Okay, it's just to change A, S, and what? Okay, just to change these two things. Are you getting it? So in this type of equation, it's in what? Vertical form. So we use any of these. But the best formula to use, let's use V square. Okay, So take note of this. A stone is thrown vertically upward, right? So I said if the stone is going upward, the final velocity is what? Is zero. And also the g is what? Is negative if the stone is going upward, because the stone is going against the force of gravity or the gravitational force. Because when an object is moving upward, the gravitational force is to what? Push that object downward. So the stone and that particular force is what? Struggling, like fighting. I get me. So it will what? Negative. Okay. So here we can do it this way: v square minus u square. Okay. We move this one to our left side. Okay. Equal to, since here is negative, which is the g, we put the negative sign, minus 2g h. Are you getting it? So the v square is 0 square, right? And 0 times 0 is still what? 0. Square means what? Two places. So 0 times 0 is still what? 0. So it will be what? We can write it this way: minus u square. Okay? 0 minus u square will still give us minus u square. So equal to minus 2gh. So if you look at the equation, we have to find an expression for the maximum height. So let's make h the derivative of the formula. So h equal to, since we have negative and negative sign, we cancel them. Okay, so h equal to what? U square all over 2g. So this is the first expression by making the maximum height, or the h the derivative of the formula. H equal to u square all over 2g. Okay, so please take note of all these laws. Okay, so let's calculate the second one: the velocity on hitting the ground, meaning the object is coming from upright, is coming downward. So take note of this. I said if the object is coming downward, meaning the initial velocity is what? Is zero, right? And also the g is what? Positive. I get me, because um, the object is coming in line with the gravitational force. Are you getting it? So we are still going to use this formula. Okay, I'm still going to use this formula. So okay, let me clean here. So v square equal to u square plus what? 2gh. So here we have v square. We can use the first form, v square minus what? U square equal to what? 2gh. Right? So I said if the object is coming downward, this initial velocity is what? Is zero. So v square minus 0 will still give us what? V square equal to what? 2gh. I get me. So they said the velocity on hitting the ground. So we are making v the short of the formula. So we want v, it will be v equal to, introducing the square root, v square root 2gh. So these are the two expressions. This is the first one and this is the second one. So make sure you know all these rules are applied. Okay, if you find this video helpful, give this video a like. Okay, like this video and drop your comment in the comment section. If you are watching on Facebook, follow this page for more videos, and please click on the share arrow and share this video for others to watch and learn. Okay, if you are watching on YouTube, subscribe to my YouTube channel for more videos. Thanks for watching. Bye.